Hello. So today we are basically going to learn what is logarithmic differentiation and where this technique of differentiation is going to be useful. So we're given a function f of x and we are asked what we need to do is find the derivative of this function. And as you can see that this function is actually very complicated. It has 1 power of 9, 1 power of 2, and 1 power of 5. So if we use the quotient rule or the product rule, then the differentiation can get extremely lengthy. And to save time, we use this technique known as logarithmic differentiation. So I will walk through that and we shall learn using this example. So let y equal to x to the 9 times x minus 9 whole squared all over x squared plus 3 whole to the 5. Now what we can do is we can take the natural logarithm on both sides. So we get that ln y is equal to the natural logarithm of this whole expression, that is x to the 9 x minus 9 whole squared upon x squared plus 3 whole raised to the 5th. Now there are some natural logarithm rules which we need to keep in mind. I'm going to list the common ones on the right hand side. So we have the natural logarithm of a times b is simply natural logarithm of a plus natural logarithm of b, and the natural logarithm of a by b is the natural logarithm of a minus the natural logarithm of b. Using these rules, we can simplify the right hand side of this function as natural logarithm of x to the 9 plus the natural logarithm of x minus 9 whole squared subtracted by the natural logarithm of x squared plus 3 whole raised to the 5. Now, to simplify this further, there is another logarithmic rule which we can keep in mind, which goes as follows: that the natural logarithm of a to the n, let's suppose, is simply n times the natural logarithm of a. Using that to further simplify what we get that this expression right here simplifies to 9 ln x plus 2 times ln of x minus 9 minus 5 times the natural logarithm of x squared plus 3. Now this was all equal to ln y. Now here what we can do is now start differentiating, and we will differentiate with respect to x. So the differential or the derivative of ln y with respect to x is simply going to be 1 by y, and because this is a function in terms of y, the chain rule applies, and we're going to multiply this by dy by dx. Now moving on to the right hand side, the derivative of the natural logarithm is simply 1 by x. So yeah, it is basically going to change to 9 by x plus again 2 times 2 divided by x minus 9 minus 5 times the derivative of this expression right here, and that can basically be simplified as the derivative of 1 over x squared plus 3, and because this is a function in terms of x squared, we have to again apply the chain rule and take its derivative and multiply it. So this will be the d by dx of x squared plus 3, which will simply be 2x. Now we see that we have sort of an equation which we can rearrange to find our subject, which is nothing but dy by dx. So doing that, we get that dy over dx is equal to 9 by x plus 2 over x minus 9 minus 10x over x squared plus 3, all multiplied by y, which we took from the other side and transferred it, so we get this. And this is our final answer, and this can be further simplified if we mention the value of y. So let's quickly do that, and we get that this is equal to 9 by x plus 2 over x minus 9 minus 10x over x squared plus 3 times y, and y was nothing but this function right here, which is simply equal to x to the ninth times x minus 9 squared divided by x squared plus 3 whole raised to the 5. And here is our final answer.